Let's solve the following differential equation. Our first step will be to rewrite a differential equation in terms of dy over dx. For that, we will consider the first term, x times x minus y times dy, and we will take the second term to the right hand side. So that will be negative y squared times dx. And dy over dx will then become negative y squared divided by x times x minus y. We can also take this negative 1 and multiply it to x minus 1 such that dy over dx will become equals to y squared divided by x times y minus x. In the next step, what we'll do, we'll divide each the numerator and the denominator with x squared such that our differential equation becomes y squared divided by x squared whole divided by y over x minus 1. Now, in this differential equation, if we consider this to be equals to the function f and make a substitution, x with lambda x and y with lambda y, we'll see that our function gives back the original function. And whenever this particular criterion is met, we say that f is a homogeneous function. And since f is a homogeneous function, that means our differential equation is a homogeneous differential equation. The next step will be to solve this differential equation. The only issue is that we cannot use the method of variable separation to this differential equation directly. The reason behind this is if we look at our function f of xy, this function cannot be expressed as the product of two functions g and h, where g is purely a function of x, times h, which is purely a function of y. Since this is not true, we cannot use the variable separation method. But if we make the substitution y over x equals to v, then our differential equation reduces to a variable separable form. So let's do that. So y over x equals to v is also y equals to v times x. Differentiating both sides with respect to x gives us dy over dx equals to v plus x times dv over dx, where we have applied the product rule to differentiate v times x. Let's rewrite a differential equation that will become v plus x times dv over dx equals to, so we have y squared over x squared in the numerator, so that's v squared divided by v minus 1. Next, we will subtract v from both sides. That means we have x times dv over dx, and combining the two terms on the right hand side, we have v minus 1 in the denominator, and in the numerator we have v squared minus v times v minus 1, so that's v squared plus v. So this v squared gets cancelled out, and this leaves us with v over v minus 1. Separating the differentials, we have v minus 1 divided by v multiplied to dv equals to dx over x. This is in the separable form. Since we have our differential equation reduced to a separable form, now we can integrate both sides. So we can integrate the integration of v minus 1 over v. So this is simply 1 minus 1 over v dv equals to integration of dx over x, or integration of dv minus integration of dv over v equals to integration of dx over x. So integration of v will be v minus integration of dv over v, so that will be natural log of v equals to integration of dx over x, so that's natural log of x plus the constant of integration. So let's consider it to be natural log of c. We'll take natural log of v to the right hand side, so that we have natural log of v plus natural log of x plus natural log of c. The three logarithms on the right hand side can be combined together using the property of logarithm. That will be v will be equals to natural log of v times x times c. Right. Now we make the substitution. Before making the substitution, we will use the property of a logarithm. So whenever we have log of a is equals to b, so using the definition of logarithm, we have a equals to e raised to the power of b. So that means we have e raised to the power of v, that will be equals to v times x times c. Now finally we make the substitution. Y over x is equals to v. That means our solution will then be e raised to the power of y over x equals to, so v will be y over x multiplied to x times c. So this x and x cancels out, and our final solution will then be e raised to the power of y over x equals to y times c, and this is the required solution to a given differential equation.